Hello everyone, I'm Dr. Ashish Bansal. I welcome you all to the fourth part of this series of videos. In this video, we shall discuss question number 15 to 18 of ISC 12 Mathematics 2024 board paper. Question number 15 has 5 parts of 1 marks each. In subparts 1 and 2, choose the correct options, and in subparts 3rd to 5th, answer the questions as instructed. This is question number 15, first part. If A vector equal to 3 I cap minus 2 j cap plus k cap and B vector equal to 2 I cap minus 4 j cap minus 3 k cap, then the value of modulus A minus 2B will be, that needs to be found. The correct answer is B. Because we are given A and B, we can compute A minus 2B vector, which is minus I cap plus 6j plus 7k. Then its modulus would be computed as root 86. Question number 15, second part. If a line makes an angle alpha, beta and gamma with positive direction of the coordinate axis, then the value of sine square alpha plus sine square beta plus sine square gamma will be. The correct option is D. The reason for the same is, we are given a line that makes angles alpha, beta, gamma with the coordinate axis, then I can write the direction cosines of this line as L equal to cos alpha, M cos beta and N equal to cos gamma. We know that L and N satisfy this identity, that L square plus M square plus N square equal to 1. Substituting values of L and N and then simplifying, we can get the required value of sine square alpha plus sine square beta plus sine square gamma as 2. Question number 15, third part. In the figure given below, if the coordinates of the point P are A, B, C, then what are the perpendicular distances of P from XY, YZ and ZX planes respectively? Now this is the point P which has coordinates A, B, C. That means this length OA is A, small a, then AD is small b, and DP is small c. So if I look at A is the perpendicular distance from the YZ plane, B is the perpendicular distance from XZ plane, and C is the perpendicular distance from XY plane. Hence, we have the required solution. Question number 15, fourth part. If A vector is 2I cap plus j cap plus 2k cap and vector B is 5I cap minus 3j cap plus k cap, find the projection of vector B on vector A. So we are given A and B vectors. Projection of B on A is given by B dot A by modulus of A. We can substitute the values and do the computations to get the answer as 3. Question number 15, fifth part. Find a vector of magnitude 20 units parallel to the vector 2I cap plus 5j cap plus 4k cap. So we are given a vector A. Let us first find the unit vector in the direction of A, and it is given by A cap equal to vector A by modulus of A. So this is the required unit vector in the direction of A. Now we have to find a vector which is parallel to A and having magnitude 20 units. So that required vector is 20A cap, which is this vector. Question number 16, first part. It's a 2-mark question with an internal choice. It says if A cross B equal to A cross C, where A, B, C are non-zero vectors, then prove that either vector B equal to vector C or vectors A and B minus C are parallel. So we are given that there are 3 non-zero vectors A, B, C such that A cross B equal to A cross C. Now if we consider B and C, there are two possibilities, there are two cases possible. Either vectors B and C are equal or they are unequal. If they are equal, then the result holds. This is one of the requirements that we wanted to establish. So the result holds in this case. So if B is not equal to C, then we compute B minus C cross product with vector A, and this is B cross A minus C cross A. I can write B cross A as minus A cross B, and we are given that A cross B is equal to A cross C. This is the hypothesis. So we replace A cross B by A cross C. So this vector is 0. So the cross product of these two vectors is 0, implies that they are parallel vectors. Question number 16, second part. If A and B are two non-zero vectors such that mod of A cross B is A dot B, find the angle between the vectors A and B. So let us assume that theta is the angle between the non-zero vectors A and B such that mod of A cross B is equal to A dot B. Now using this equality, look at the left hand side, modulus of A cross B, it can be written as mod A mod B sine theta, and A dot B is mod A mod B cos theta. Since A and B are non-zero vectors, so their modulus are also non-zero numbers, so they can be cancelled. So we get sine theta equal to cos theta. This implies tan theta equal to 1, which implies theta equal to 45 degrees, which is the required angle. Question number 17. It's a 4-mark question. It says a mobile tower is situated at the top of a hill. Consider the surface on which the tower stands as a plane. So this is the plane where the tower PQ is standing. And there are 3 points A, B and C on it. So these are the 3 points A, B, C on this plane where this tower PQ is standing. And these 3 points are tied with the 3 cables from the points A, B and C such that it stands vertically on the ground. So in order to make this tower stand vertically, there are 3 wire cables which are attached. The top of the tower is at the point P231. The point P has coordinates 231, and the Q is the foot of the perpendicular from P on the plane, and the coordinates of Q are also given to us. So there are 5 points here, P, Q, A, B, C, and we know the coordinates of all the points. You have to answer the following questions. Find the equation of the plane containing the points A, B and C. Second, find the equation of the line PQ. Third, calculate the height of the tower. So given a plane passing through the points, these 3 points, this we know because the given plane passes through these 3 points, so we can find the equation of the plane using the 3-point form. So let us assume x1, y1, z1 as 1, 0, 2, x2, y2, z2, x3, y3, z3. So equation of the given plane will be of this form that can be computed easily. Second is we have to find the equation of the line through points P and Q. So we can find the direction ratios of the line PQ. So these are given by 43 by 29 minus 2, 77 by 29 minus 3, 9 by 29 minus 1, which can be simplified to get 3, 2, 4. Equation of line PQ will be x minus 2 by 3 using this point, y minus 3 by 2 and z minus 1 by 4. 3 to 4 are the direction ratios, so they come in the denominator. Third part is height of the tower. We know the coordinates of P and Q. We can find the distance between them to get the required height of the tower as 5 root 29 units. So distance formula can be used. Question number 18, first part. It's a 4-mark question. It has an internal choice. It says using integration, find the area bounded by the curve y square equal to 4ax and the line x equal to a. So these are the given curves. I can write this first curve as y equal to plus minus 2 root a root x, and second curve is x equal to a. So I can write the table in this form. For corresponding values of x, we can get the respective values of y, and these points can be used to plot the curve. So this is y equal to 2 root a root x, and this is y equal to minus 2 root a root x. These are the two branches of this parabola, and this is the line x equal to a. So the area bounded is this, and the area of the required area is integral between 0 to a of the upper curve, which is 2 root a root x, minus this lower curve, which is minus 2 root a root x. So that can be simplified to get the answer as 8a square by 3 square units. Question number 18, second part. Using integration, find the area of the region bounded by the curve y square equal to 4x and x square equal to 4y. So these are the given curves. The first curve is y equal to plus minus 2 root x, second is y equal to x square by 4. Now, if we compare the two equations, we get x as 0, 4. So we get the point of intersection of the two curves, and some points can be plotted by putting x0, y0, and these points can also be substituted here. These tables help us in plotting the graphs of the curves. So we get these graphs. The required area is integral from 0 to 4. Upper curve is this one, y equal to 2 root x, and the lower curve is y equal to x square by 4. So we can compute this integral to get the required area 16 by 3 square units. So that's all for this video. Thank you so much. For rest of the solutions, kindly watch the upcoming videos.